Check. Hey. Sorry if you're here and you heard me checking. Having multiple house issues right now, so I apologize. So I accidentally ran over my power cable while mowing the lawn. Wait, ruined everything. And so things are crazy right now. So I did make it back in for this. And I'm hoping to see your faces. Your friendly faces. Or your friendly comments and chats. Looks like my internet's still working, so that's good. Which means I am live. Hey Jessica, welcome. Hope your day is going better than mine is so far. I have been a disaster so far today. Unmitigated. What happened? That's the related to the bottom question. So I was gonna see if anybody could figure it out before I spoil the beans. Although I think I already spilled the beans at the very beginning when I was trying to get things to work. Slash, it just happened and I had to run back inside, so. Panic. Oh, and my friend's not coming over. Okay, so that actually makes it a little. Yeah, straight disaster. Yes, but why did the power go out? Because it is related to the power outage. But what caused my power to go out? That's the real question. And how am I still able to stream? So this stream will understandably maybe be a little bit shorter even than normal because my house is in utter disarray and things are chaotic. It's kind of funny. And we didn't cover a ton of new stuff since the last stream. We had a review assignment, so I'm happy to talk about anything from our previous chapter. And then we had graphing square roots and domain and range, and I wanted to make sure to talk about that here in case people have questions about that. So that's kind of the focus of this. Because we're going to be doing a lot more domain and range stuff in the very near future. That's most of what chapter 10 is. And actually why we're having a worksheet next class instead of an actual online assignment, which is going to be weird. And I'm going to have a Google form for people to upload that assignment to. And I'll probably be posting that today or tomorrow, a little bit early, in case you want to take a peek at it. Oh man, my phone's blowing up because of all the chaos. Uh-oh. Oh man. Oh yeah, I can full screen this. I don't need to have it in flame form. Feel free to spoil answers if you have figured any of these out. Hello to those of you who've showed up and can't comment or that sort of thing. Trying to think if there was a way I could make it so that people who aren't logged in could comment. I've heard that some people show up to this not logged in and watch it, but aren't able to comment. So I don't know how to allow that. Sorry, folks. Hello, Alex. Welcome. We got a fair amount of stuff from last unit. That's 1 and 2, and then some stuff from the most recent assignment, which is 3 and 4, which only a handful of people have done this far, but helps to during this live stream cover the stuff that is maybe a little bit harder for folks. I don't think you're going to be able to put your answer in chat for question 3. That's probably a little too hard to put into chat. But I will be drawing it on the screen / maybe throwing it in Desmos to show how to do it when I go over these. If you get stuck at any point and just want me to start going over it, feel free to holler at me, or if you just want me to start going over it, you can tell me that, and I'm happy to do that. I'm happy to talk about things or give you time to work on it. Either fine with me. Got y squared 7xy. So Jessica, the y squared is cool to pull out, but there is more you can still pull out of that. Notably the number. Welcome, Caden. Hello, hello. Mostly going to be talking about square roots and domains and ranges. Oh. Wonder why it hid your comment, Alex. Show it, because I don't know what's dirty there. Maybe it's the symbol? Yeah, yeah. You guys both got it now. Nice, nice. No Danica here this time to spoil all the quadratic formula questions. Very early. Not yet. I hope you all have been staying safe. The world is a scary place. Yeah. Things have been a little hairy. Yeah. But hey, at least I got the date right on this. Feels good. This is more common than I get it right in class. On these, I actually remembered to put correct date at the top. Proud of myself. Number 2, no solution. No, number 2 does have a solution. It's a weird solution, fairly janky, but it does have a solution. Notably because some slight spoilerinos here. This a times c multiplying to give a negative means there's always a solution, because the minus for AC in the quadratic formula cancels with the negative, and you always get a solution if your a times c multiply to be a negative. And Caden, feel free to spoil any of these if you figured them out. Alex and Jessica both spoiled question 1. Or anybody who showed up sitting quietly and also. Being here just to refresh my mind on how to do these. Alright. Well, now that the answer's there, can you figure out question 1? Maybe? The doing questions is definitely the best way to see if you know how to do questions. Hey, Vachin. Welcome. You're here early enough this time. I think last time you showed up right at the end. Near the end? 13 minutes late. That's like Great Mason. My most famously. Probably those two. Even in calculus, my first period there is better than those two gentlemen. Two-thirds and negative. Oh. Yeah, Alex, I think you're there. I think you're there. Wait, Nick. Yeah, that's right. Check. Nice. Nice. Alright. I think I'll start spoiling these in a minute or so. Because then we'll be at about the 15-minute mark since it started. Alrighty, I'm going to start going over 1 and 2, so hopefully that's not too egregious to the people who are working through the later ones and maybe want a chance to try those out. In 1, 2 things actually split. The x has nothing to split to, but the y to the 5th is y, like this, and you can circle the pairs, which allows you to pull out a y squared. And the 27 can be split up as 3 times 9, and 3 and 3, and then you can pull out another pair. That's how people were able to pull out a 3y squared, and what was left inside was 3, x, and y. And so that was our remaining piece. For number 2, we used our boy, the quadratic formula. X is equal to negative b plus or minus the square root of b minus 4ac all over 2a. And if we use this equation and plug in all the stuff, which is notably that a is 3, b is 1, and c is negative 2, then you get -1 plus or minus the square root of 1 minus 4 times 3 times -2 all over 2 times 3. Ooh, Alex is starting to answer 4, technically. The domain and range is 4. And if you simplify this, you get -1 plus or minus the square root of 1 plus 24, which is what 2 times 3 times 4 is, because the negatives cancel, all over 6, which is -1 plus or minus the square root of 25 over 6, which is -1 plus or minus 5 over 6. And this is how you get to Alex's answer. -1 minus 5 over 6 is -6 over 6, or -1. And -1 plus 5 over 6 is 4 over 6, or 2/3. And so those were the answers, were -1 and 2/3. And those are the answers to question 2. But that one was definitely the one that took the most writing. Alright, if you haven't seen the most recent video, this is what's on there. If you have to graph a square root function, you basically, the easiest way to think about these is, what do I plug in for x to get 0 inside the square root? And that's 4. 4 minus 4 is 0. This graph starts at 4. And if you plug 4 in here, you get 0 for y. So 4, 0 is the starting point. There is another way to think about this, and I'll go over that in a second, but I wanted to start with this way. 4, 0 is like here. And then we're going up 1 over 1, and then over 4 up 2, because the square root of 4 is 2, over 9 up 3, and you should get a graph that goes up like this, being less and less steep as it goes up. Okay, the other way to think about this is that because the 4 is subtracted on the inside of the parentheses next to the x, this is a right 4 shift. And so all we do is move right 4, and then we start a square root graph, which means we go over 1 up 1, because the square root of 1 is 1, and we go over 4 up 2, because the square root of 4 is 2, and so on and so forth. And then the last way to think about this is remembering the equation that I talked about during my video, which was this, or that you probably got if you clicked on the help me in class Pearson, whatever Pearson's called now, I forget their name. And all we see is that there is no plus k on the outside, so we're shifting up 0, but there is a minus h, and the h is a 4. And so 4 is where we start this graph, at 4, 0. Any of those ways get you the starting point for the square root, and then from that point, all you do is do over 1 up 1, over 4 up 2, and that gets you there. All right, let's check out Alex's answer for 4. Domain goes from 4 to infinity. Range goes from 0 to infinity. That is exactly right. So if I look at this graph, it starts at 4. So the domain is, I start at 4, and I go all the way over to the right forever. Remember, domain is x values, so my x values for this graph, for the curve, start at 4 and go right forever. My range is my y values. My y values start at 0, and then go up all the way till infinity. Now, you didn't have to actually write your answer this way. There was another way to write your answer. This is the way Alex wrote it, and it's 100% right. But you actually can get away without even writing this up to infinity thing, because if you just say x is always greater than or equal to 4, and is everything there, then you don't need the less than infinity piece. And if you just say y is greater than or equal to 0, you've covered everything. It means it goes through every point and goes up forever. So you don't need the up to infinity piece. And so there's actually some leeway with these, and you can get away with writing very little. Oh gosh, I had my eraser on. Oopsies. Which is kind of nice. If you want to. All right. Now let's see if people can figure out how I managed to unplug my garage door, or ruin my garage door temporarily, that I have to go fix after this stream ends. Because my fridge is also... gives a little hint. It's unemployed. I mean, currently. You broke the string. That's actually closer to the truth than you might think, but I did not break the string for the garage door. I ran into it. I did not do that. Yeah, I definitely didn't do that. Yeah. Yeah, the drove into it seems like the most common answer. But that wouldn't ruin my fridge, I don't think. It just broke by itself. I wish. Then it wouldn't be my fault and I wouldn't feel bad. Alright, so, ran out of battery. That would also be nice. If it was on battery, it wouldn't be broken right now. Like, if it ran out, I'd just fix it. Like, whatever, dude. Yeah, so, turns out, the power is out for part of my house, anything on a GFCI outlet, which are the special kinds of outlets, because while I was mowing my lawn, I ran over the cable and snapped it, and when I did, I shorted the power in my house. And so, anything on a surge protector outlet got shorted on the same string as the outdoor outlet. And so I actually, like, totally wasted all the power while mowing my lawn. Feels bad. This is what I get for having a corded mower. And I also don't now have a cable long enough to mow my lawn, so feels bad. So yeah, it's definitely all my fault because I snap. Sad panda. Don't mow your lawn. Now, interesting story on that. I actually got in trouble because my lawn's kind of ratty because I hurt my ankle and I'm the only one who mows the lawn in my house. So because I was hurt for a while, I couldn't mow my lawn, and I got yelled at by our homeowners association for having a nasty lawn. So I went out to go fix it today, and I cut my cable, so now I can't mow my lawn. So I'm in a world of hurt right now. Yes, I can open my door manually, and I was actually able to close it manually with that, but now my wife can't get in the house. That feels bad. Because I don't know that she has a key to the house because she just uses the garage all the time. So I'm gonna go let her in. Feels bad. I gotta go fix that soon, but I don't 100% know how. I know there's a way. I might need to go get a fuse or something. So are there any other math questions that my Algebra 1 folks have? Before I go fix my house. Because I'm happy to do more examples of square root stuff, maybe show some domain and range examples. I could show like upside down square roots or things like that, backwards square roots. So I'm happy to kind of do anything related to that would help anybody. Or I can talk about things from last unit if that would be helpful for you. Hey, Diego. Hey. That's cool. Is Diego hanging out with you right now, Vachin? Okay. Just via other times or online or something? Well, the newest thing we have learned, y equals the square root of x minus 7. How do we find the x and y? Oh, he just texted you. Nice, nice, nice. Okay, so, yeah, let's just look at okay, y equals the square root of x minus 7, like this, or Actually, why don't we look at both of them? Both of the interpretations of what you just wrote. Which are these? In this one, okay, so to look at the formula, square root of x minus h plus k. A number on the outside is up or down. So it's your y-coordinate of your starting point. And h, the number on the inside, is your left or right. And so the opposite of it is the x-coordinate. So in this case, the opposite of -7, the thing that's subtracted from x is 7. So this is right 7. Or we go through 7, 0 for our starting point. So the graph would look something like this, where this is 7, 0. In the other case, where we have square root of x minus 7, with the -7 being on the outside, this means down 7, because this is like a plus k here, and so whatever that number is how far we shift up or down, just straight up. And so this is down 7 because it's a -7, and so this would be a graph that shifts down 7 here to 0, -7. And then we go over 1, up 1, and it looks something like this. Now, what happens if I have both? So let's look at y equals the square root of x minus 7 minus 7. Ooh. Here, we'd shift right 7 and down 7 to 7, -7, and then we'd start our dude over here, and I'd go like that. This really isn't too horrible. If you want to find any points on this, like, you just plug in the point. So, like, let's say I want to find the value at 8. You just plug 8 in here, and you get square root of 8 minus 7 minus 7. That's 1 minus 7, so that's -6. And so 8, -6 is a point. Cool. So, Caden thinks this is pretty easy. I'm going to throw a little curveball and just show you kind of a little bit of a tricky one here. Let's say we have something like y equals the negative square root of -x plus 4. This throws curveballs. So this negative on the outside means that this graph, instead of going up like this, is going to go down like this. It's a reflection over the y-axis. The negative here means instead of opening up the forward way like this, we're going to open up the backward way. So actually, we're reflecting over the y-axis and the x-axis. Now, the cool part about this is you can still think, what do I plug in to get 0 in this parenthesis? And it's a 4. So this thing starts at 4, 0. But then it does this, because it gets flipped both over the x-axis and over the y-axis. Flip over x, then flip over y. And it ends up looking like this nonsense. So this is about as horrible as these get. And it's a little preview into the kind of stuff we're going to be doing over the next few days. We're going to be doing this with quadratics, lines, all the other things we've studied, exponentials, square roots, blah, 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 all that stuff. So yeah, this was the uber horrible question with double reflection and harder than anything on the homework, and just a little taste of where we're going. Thank you for the question, Caden. I'm happy to answer any other questions. Looks like we're actually at our peak viewership here, half an hour in. Happy to answer anything square rooty or quadratic-y. Or go fix my garage and fridge. All right. Looks like view count is dropping. Looks like questions are drying up. So I'm happy to call it here. Thank you to those of you who showed up. Hopefully you learned something. Hopefully this was helpful. I hope you guys can stay safe and, stay getting smarter and all that. Yeah. Miss you guys. Miss Diego. Miss all the people who talked in chat and all the people who didn't talk in chat. You guys are awesome. I'll be putting in credit. Looks like it's a lot of the same faces.